Greetings from Forbest Academy. In this video, we are going to be looking at the AMC 8 2025 competition. And as the instructions point out, you only have 40 minutes to solve this entire competition. That can be pretty tough, especially because the last few questions are pretty time consuming. However, it is possible to finish the entire competition and still beat the 40-minute time limit. And this video is designed to help you gain the thought processes needed to smoothly and quickly go through the whole competition and beat the 40-minute time limit. So let's get that 40 minutes on the clock right now, and let's get started. Question number 1. The 8-pointed star shown in the figure below is a popular quilting pattern. What percent of the entire 4x4 grid is covered by the star? Okay, so there's a couple ways to do this. You can notice each quadrant, you have 1, 2, 3, 4 triangles, and each triangle is half of a square, so it's 50% B. So that was an easy first question. Number 2, the table below shows the ancient Egyptian hieroglyphs that were used to represent different numbers. For example, the number 32 was represented by these 3 N's and 2 bars, because each N is 10 and a bar is 1, so yeah, 32. What number was represented by the following combination of hieroglyphs? Okay, so this is a 10,000, 4 candy canes is 400, 10,000, yeah, it's going to be B, 10,423. 2 10s and 3 1s. So the answer is going to be B, obviously. That's the only one with 10,000. So that was another easy question. Number 3. With longer questions, it actually helps if you read the last sentence or last question first. Suppose two more friends join the next game. How many cards will be dealt to each player? Okay. Buffalo Shuffle is a card game in which all the cards are distributed evenly among all players at the start of the game. When Annika and 3 of her friends, so that's 4 people, Annika plus 3, play Buffalo Shuffle, each player is dealt 15 cards. So 4 times 15 is 60. Suppose 2 more friends join the game, so we're up to 6 friends. 60 over 6 is 10. How many cards will be dealt to each player? So we're looking for 10. The answer is C, 10. Moving on. Lucius is counting backwards by 7s. His first 3 numbers are 100, 93, 86. What is his 10th number? So we're looking for 7 numbers down the road. That will be 7 times -7, or 86 minus 49. 7 times -7 plus 86. So 86 minus 49 is 46 minus 9, which is 37B. You can also say the 10th number, or 9 numbers after 100, is 63 less than 100, which will also give you 37. What is the shortest distance in blocks she can drive to complete the route? Betty drives a truck to deliver packages in a neighborhood whose street map is shown below. Betty starts at the factory labeled F and drives to location A, then B, and then C before returning to F. What's the shortest distance? Okay, so she can't just cut across these squares because these are city blocks. So we just got to follow the road. It doesn't matter if you go like this, or like this, and this. It actually comes out to the same amount because you're always going so much to the side and so much up and down. So let's just take the most straightforward way. 1, 2, 3, then B, 6, 8, 10, 12, 13, 15, 17, 19, 20, 22, 23, 24, C, 24. All right. Saku writes the numbers 15, 16, 17, 18, 19. After she erases one of the numbers, the sum of the remaining four numbers is a multiple of 4. Which number did he erase? So the sum right now is going to be 5 times the middle number, since we have a steadily increasing sequence. 17 is the average, times 5 is 85. 85, if we erase the lowest, 85 minus 15 is 70. If we erase 16, 69. If we erase 17, 68, that's a multiple of 4. So the answer is none other than C, 17. 17 times 4 is 68. So 68 was a multiple of 4. And we got 68 when we erased 17. Okay, I'm going to read the last line first. How many students earned a score of at least 80% and less than 90%? On the most recent exam, 5 students earned a score of at least 95%, 13 got at least 90%, 27 at least 85%, 50 students at least 80%. So we care about 80%, 90%, so we're looking at the 13 and the 50. 50 got 80 or above. We don't care about the 13 who got 90 or above because we want less than 90. So 50 are above at 80 or above, but we don't care about those 13 that were above 90. So from the 15, we take away 13, and there's 37 in this range here. So D, 37. Yeah, that's correct. So Isaiah cuts open a cardboard cube along some of its edges to form the flat shape shown on the right, which has an area of 18 square centimeters. What was the volume of the cube in cubic centimeters? So 18 over 6 is 3. The area of each of these is 3. The side length is root 3. And you cube that to get the volume. So root 3 times root 3 times root 3 is 3 times root 3. So our answer that we're looking for is A. Okay, easy. Keep going. Ningley looks at 6 pairs of numbers directly across from each other on a clock. She takes the average of each pair of numbers. We have 1 pair here. What is the average of the resulting 6 numbers? So the average of 2 and 8 is 6. And the average of, 2 and 8 is 10 plus divided by 2 is 5. Average of 3 and 9 is 12 over 2, which is 6. 4 and 10, 14 over 2 is 7. 16 over 2 is 8. 18 over 2 is 9. 7 and 1, 8 divided by 2 is 4. So we have the average of, we can actually write this here, and then we have a increasing list. The average is going to be right between 6 and 7 because of the fact that we have this nice sorted list, and it's got a constant difference of 1. So yeah, the average is 6.5 B. All right. In the figure below, what is the total area in square inches covered by the 2 overlapping rectangles? So in the figure below, ABCD with sides length AB equals 5 and AD equals 3. Rectangle ABCD is rotated 90 degrees clockwise around the midpoint of side DC. This is the midpoint, so this is 2.5. So we rotated that to get this shape. This is 2.5, this is 2.5. And this 2.5 swung up here to make this 2.5. So this area here is 2.5 squared, which we should know is just 100th of 25 squared, 6.25. So the area of each big rectangle is 15, and we have 2 of them. And then we have to subtract this thing, which it's overlapping, so we don't have to count it twice. So we get 23.75. 23, is that right? 30 minus 7 is 23, but then we can add back 0.75. So yeah, 23.75 D is the answer. So let's keep going. At least one of the tiles is an S tile. What are the other two tiles? A tetromino consists of 4 squares connected along their edges. There are 5 possible tetromino shapes. IOLTS, okay, shown below, which can be rotated or flipped over. 3 tetrominos are used to completely cover a 3x4 rectangle. At least one of the tiles is an S tile. What are the other two tiles? Let's just randomly plop this S tile in. Let's just put it here. So we could put an L here and an L here. That works. If we put an S here, yeah, we could put an L here and an L here. Just have to be careful we don't put it there and then cut off this block. So L and L work. C. These options don't make sense. So L and L, answer is C. The region shown below consists of 24 squares, each with side length 1 centimeter. What is the area in square centimeters of the largest circle that can fit inside the region, possibly touching the boundaries? So let's just put it, because this looks so symmetrical across 2 axes, actually multiple axes, 4 axes. Let's put the circle in the middle there. What's the biggest radius? We couldn't give it a radius of 3 because they would go outside there. If we gave it a radius of, so we don't want it touching this point or this point. What if we touch here? This has a radius of 1 squared plus 2 squared. So root 5, this is root 5. It would touch these points. That seems okay. So root 5 squared times pi is 5 pi. Answer is C. Each of the even numbers, 2, 4, 6 up to 50, is divided by 7. The remainders are recorded. Which histogram displays the number of times each remainder occurs? So we only have even numbers divided by 7. So what hits me first is that, okay, 0 could be a remainder. That would only happen if we're dividing by a multiple. We're dividing a multiple of 7 by 7. So we're looking for the even multiples of 7. How many even multiples of 7 are less than 50? We got 14, 28, and 42. So there's only 3. So it could be this, it could be this, it could be this, it could not be this, it could not be this. So what's the difference between these 3? 3, 4, 4, 3, 4, 3, 4, 4, 3, 4. So 3, this is a difference. So what's the remainder? We get a remainder of 3, which is odd. We're dividing an even number by 7, and we're getting an odd remainder. So we have multiple of 7 plus odd equals even. So we're looking at odd multiples of 7 less than 50. So we have 7, 21, 35, 49. But you wouldn't get a remainder of 3 if you divided. You wouldn't be able to divide 52 from this list by 7 and get a remainder 3. So we're not concerned with this multiple of 7. We would only get a remainder of 3 if we're dividing 10, 24, or 38 by 7. So 3, this is 4, this is 4. So we're looking at A. A is our answer. Good. Moving on. A number n is inserted into the list 267, 728. The mean is now twice as great as the median. What is n? The mean is now twice as great as the median. So let's see what the mean is now. We have 8, 15, 22, 50. The sum is 50, and we divide by 5. So it's 10. And the median is this middle number 7. So if we insert a number, if it was a low number, just say we inserted it here, then our median would still be 7. And we did not increase the mean. So our median, and even that would be true even if we inserted here. So our number is greater than 7. And so if we insert 267, 728, if we insert here, then our median is still 7. So the median is not changing. So our new mean is going to be 14, twice 7. So we have the sum plus the new number, call this n, divided by 6 equals 14. So 50 plus n equals 84, n equals 34. Let m and m equal the least and greatest possible number of gold on gold pairs respectively. What is the value of m plus m? K draws a 6x6 grid. He colors 13 of the unit squares silver and the remaining squares gold. So 6x6, so this is 36 squares, 13 is silver, 23 is gold. K then folds the grid in half vertically, forming pairs of overlapping unit squares. So what's the sum of the least and greatest possible number of gold on gold pairs? So the least would be if you just dumped 18, 6 times 3, 18 on one side, and then had 5 gold on the other side, they would overlap with pairs on the left side. So m, lowercase m, would be 5. And the way to get maximum overlap is to scatter the 23 evenly as possible on the two sides and in corresponding locations so they meet when the paper is folded. So 23 divided by 2 is 11, remainder 1. So you'd have at most 11 pairs. So the sum is 16, C. 5 distinct integers 1 to 10 are chosen, and 5 distinct integers from 11 to 20 are chosen. No two numbers differ by exactly 10. What is the sum of the 10 chosen numbers? Okay, so these kinds of questions can really confuse you because you think, well, like, there's so many combinations I could go through, but there must be something in here where it doesn't really matter what numbers you choose because there's some hidden kind of phenomena or hidden mechanism that means you get the same result regardless of what you choose. So let's just say I chose these 5 numbers here. I can't choose these 5 numbers, so I got to go with these 5 numbers. I can think of this as 10 plus 10. So I get the sum of 1 to 10 in the ones digit plus 5 additional 10s. So the sum of 1 to 10 is equal to 10 times 11 over 2, which is 55. And then the sum of 5 times 10 is 50. Add that together, I get 105. How are we doing on time? Okay, let's try to pick up the pace a little bit. How many people work in A? In the land of Markovia, there are 3 cities, A, B, and C. There are 100 people who live in A, 120 who live in B, and 160 who live in C. Everyone works in one of the 3 cities, and a person may work in the same city where they live. In the figure below, an arrow pointing from one city to another is labeled with the fraction of people living in the first city who work in the second city. So, for example, 1/4 of people who live in A work in B. How many people work in A? So the number of people who work in A are the people who don't leave A plus the people coming in from B and C. We got 100 people in A, 120 in B, 160 in C. An eighth of 160 comes to A third of 120 comes to A, and then we have A minus a quarter minus a fifth. So we're losing 9 out of 20, which is 45. So we have 55 left over. Let's sum up these numbers and we get 75 plus 40, 115B. Good. Let's keep going. What is the radius r in units of the circle on the right? The circle shown below on the left has a radius of 1 unit. The region between the circle and the inscribed square is shaded. In the region shown on the right, 1/4 of the region between the circle and the inscribed square is shaded. Yeah, 1/4 is shaded. The shaded regions in the two circles have the same area. What is the radius r of this one? So things got blown up here by a factor of x. And so area is going to be proportional to x squared. The difference in the two areas is still going to be proportional to x squared. But we also have only 1/4 of that area. We got we're only concerned with 1/4 of the area, and that is still equal to this whole area. So we have 1 times x squared, 1 times x squared times whatever area this is, divided by 4 is equal to the same area. So we have x squared equals 4. I could have just said r squared. R squared equals 4, r equals 2. So r is 2, B. How far from town A in miles will the two cars meet? Two towns A and B are connected by a straight road 15 miles long, traveling from town A to town B. The speed limit changes every 5 miles from 25 to 40 to 20 miles per hour. The two cars, one at town A and town B, one at town B, start moving toward each other at the same time. They drive at exactly the speed limit in each portion of the road. How far from town A in miles will the two cars meet? So looking at the first sections, A is going faster than B. So A is going to finish the first segment before B does. So they can't meet in A, obviously. They can't meet in this section, obviously. How long does A take to finish this? 5 over 25 is a fifth, so 0.2 hours, whereas B will take 5 over 20, a quarter hour, 0.25 hours. So for 0.05 hours, A is into this section and will travel 0.05 times 40, which is 2 miles when B is here. And then they will meet in the middle here. So remaining 3 miles here divided by 2, 1.5. This is 8.5. So the answer is D, 8.5. Whereas this guy went 6.5 from B, but we're not concerned with that. So the answer is D. 20. Sarika, okay, what's the last line? About what fraction of the original block of cheese does Sarika eat in total? Sarika, Dev, and Rajiv are sharing a large block of cheese. They take turns cutting off half of what remains and eating it. So if you eat half, you leave half, and then if you eat half of this part is equal to that. So this was a quarter, this will be a quarter, and they keep going. First, Sarika eats half of the cheese, then Dave eats half of the remaining half, then Rajiv eats half of what remains, then back to Sarika, and so on. They stop when the cheese is too small to see at what fraction of the original block of cheese does Sarika eat in total. So first, Sarika will eat a half. This guy has a quarter, this guy has an eighth, then she has a 16th. And so we can see the pattern. It's an infinite geometric series with common ratio of 1/8. So we take the sum of the infinite geometric series. With the first number is a half. 1 minus an eighth is 7/8. This is like 4/8 over 7/8. So our answer is 4/7. A. Good. Königsberg School. What is the sum of the grade levels assigned to pods C, E, and F? The Königsberg School has assigned grades 1 through 7 to pods A through G, 1 grade per pod. Some of the pods are connected by walkways as shown in the figure below. The schools noticed that each pair of connected pods has been assigned grades differing by 2 or more grade levels. For example, grades 1 and 2 will not be in pods directly connected by a walkway. What is the sum of the grade levels assigned to pods C, E, and F? Okay, so we noticed that F looks quite busy, and so does C. F has how many connections? It has 1, 2, 3, 4, 5 connections. C has 1, 2, 3, 4, 5 connections. So if we look at the numbers 1 to 7, how many ways can we have? Just say 2 can't be connected to 1 or 3. So there would only be 4 connections, not possible. So we know C and F cannot be in the middle. So they have to be out here so that, say, 7 can't be next to 6, but it can be to any of these 5. And 1 cannot be next to 2, but it can be next to any of these 5. Let's just assume this is 1 and this is 7. Assume that it works out. You get the same sum regardless of what you do there. Which means that E is probably going to be the middle number for that to be true. But let's just prove it. So D, if this is 1, D must be 2 because it's not connected to F. And if this is 7, the one not connected to C is G, so this must be 6. This could not be 3, and 1 and 2 and 7 are taken, so it could only be, and 6 is up there, so it could only be 4 and 5. If we put a 5 here, that means 3 and 4 are here, but then they'd be touching, so this must be a 4. And then we're left with 5 and 3. So we could just make this 3, so that's not, 5 isn't touching there. Hey, that works. So then 1, 4, and 7, the sum is 12. A. Okay. 22. How many different numbers of coats can satisfy Paulina's pattern? All right. A classroom has a row of 35 coat hooks. Paulina likes coats to be equally spaced so that there is the same number of empty hooks before the first coat, after the last coat, and between every coat and the next one. Suppose there is at least one coat and at least one empty hook. How many different numbers of coats can satisfy Paulina's pattern? So we got 35 coats. So our number of empty coats, just say C is our number of coats. We would have 35 minus C, number of empty hooks, and that would be divided over C plus 1 sections. So with C1, we're looking at 34 over 2. And let's see how many, as C increases, we're going to look for 33 over 3, 32 over 4, 31 over 5, 30 over 6, 29 over 7, 28 over 8, 27 over 9, 26 over 10, 25 over 11, 24 over 12, 23 over 13, 22 over 14, 21 over 15, 20 over 16, 19 over 17, 18 over 18, 17 over 19 is not even 1. That won't work. This will work. That's not integer, not integer, not integer, not integer, not integer, good. No, good, no, good, no, good. So we're looking at 1, 2, 3, 4, 5, 6, 7 ways we can do that. Okay, so we solved that by brute force, but we did it pretty quickly. How many 4-digit numbers have all three of the following properties? The tens digit and ones digit are both 9. The number is 1 less than a perfect square. The number is the product of exactly 2 prime numbers. So we're looking for, so 1 less than a perfect square, that means it's a difference of squares. And we know these are 99 and 1 more than that. So it would be a number, if you add 1, you'd get something 100 that is a perfect square. So we're looking at like 1599, 2499. So that's 39, 49, 59 squared. So 1 less than 36, 1 less than 60 squared, 1 less than 70 squared, 1 less than 80 squared, 80 squared would be 399, 1 less than 90 squared, 1 less than 100 squared. Okay, so this is difference of squares. So 39 is not prime. This is 49 is not prime. This is 59 times 61, that works. This is 69 times 70, 69 is not prime. 79 times 81. Is that right? Yeah, 79 times 81. That works. This is 89 times 91. 91 is not prime. And this is 99 times 101. 99 is not prime. So we have 79 times, 81 is not prime, sorry. 81 is 9 times 9. That definitely does not work. So we only have one, option B. Okay, that was close. In trapezoid ABCD, angles B and C measure 60 degrees and AB equals DC. The side lengths are all positive integers and the perimeter of ABCD is 30 units. How many non-congruent trapezoids satisfy all of these conditions? Okay, so we got, if B is 60 degrees, if we extend this line, that's 60, this is 120, this is 120. Let's draw a 90-degree angle down. This is 90. So this is a 60, 30, 90 triangle. We know a property of this triangle is if this distance here is x, this hypotenuse is 2x. So this is x, this is 2x. Let's call this distance y and y. So we have 2, 3, 5, 6x plus 2y is having a perimeter 30. So 3x plus y equals 15. X could be at most 5, but then y would be 0. So x could be up to 4 and minimum 1. And if x was 2, 6, yeah, so if this is x, this is y, this would be 12, 9, it's going to decrease by 3 each time. These all work. These are all viable solutions. So we have 4 solutions. And now we're already on the last question. What is the sum of the areas determined by all possible paths? Michaela finds all the possible ways to draw a path in a 5x5 diamond-shaped grid. Each path starts at the bottom of the grid and ends at the top, always moving 1 unit northeast or northwest. She computes the area of the region between each path and the right side of the grid. 2 examples are shown in the figures below. What is the sum of the areas determined by all possible paths? Okay, so let's figure out how many paths are there. Classic combinatorics problem. You got to go 5 in this direction and 5 in this direction. You're making a total, your line is a total length of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're making 10 moves, and 5 of them are right. 5 of them are, I'm saying this is right and this is up. So it's 10 choose 5, which is going to be 10 times 9 times 8 times 7 times 6 over 120. Well, this is 5 factorial, and then we're dividing by 5 factorial, and then we're dividing by 5 factorial. So 120 is the same as 60 over 120 is the same as 1 over 2. And simplify this. So we get 36 times 7 is just 210 plus 42, 252 ways. And notice that the total areas on the left side, if we flip this 180 degrees, this would be a viable solution to the problem. So the total areas on the left side are going to equal the total areas on the right side. It's just that at any given time, the area on the left side is equal to the area on the right side minus 25. So we have total areas left plus total areas right is going to be equal to 25, because this and this adds up to 25, times the number of paths. But we just want total area on the right, so we divide this by 2. So we have this divided by 2 is 126 times 25, which is 120 times 25 plus 6 times 25. This is the same as 120 times 100 divided by 4, which is 30, 100 plus 150, 3150. Answer is B. Okay, so we're done. So we finished just at around 40 minutes. I hope this video was helpful. If you found it helpful, please watch it again and watch it as many times as you need to help you to absorb those thinking skills you need to think quickly and calmly during the test. And please like and subscribe to this video. Thank you for watching, and we'll see you next time.